All right. Hello and welcome back. Our class of Eurocode 7, Geotechnical Design. So we are still on chapter number 3. I think this is the second video on this chapter. And in this video, we will talk about this 4 point. And the video is not really that long. And next video will be only in this, some example. We will try to do some example on characteristic value of some ground parameters. Okay, so previous video was on these 3 first point. This video is about these 4 points. Okay, so field testing, laboratory test, and characteristic value of geotechnical data. I think the all ground investigation and testing is about this characteristic value, how we can obtain this characteristic value. Okay, so let's go with the field testing first. Field test. What is Eurocode saying about the field test? The following field tests are covered in the second part of Eurocode 7. Okay, the cone penetration test. The cone penetration test, we have cone penetration and piezo cone penetration test, CPT and CPTU. The difference is very simple. In CPTU, we measure also the water pressure. That's why the UCU. That's the difference. This is something like that. The cone is here, and the test will give you this the friction Fs and QC, the cone tip stress. Okay, and from this value you can obtain more information about soil parameter. Yeah, I'm not going to give all detail of this test here in this video because there is another program that will focus on lab and field tests. Okay, here maybe just the names. You will see only the names. So this test and also pressure meter test, PMT, flexible dilatometer test, FDT, standard penetration test, SPT, dynamic probing test, DP, weight sounding test, WST, field vane test, FVT, and flat dilatometer test, DMT, the plate loading test, LPT, and all these tests are covered in the second part of Eurocode 7. Okay, so later we will make another program, another playlist to talk about only field test and lab test. Okay, but this video is just to show you the different type of tests covered by Eurocode 7. So we will also discuss evaluation of some field tests, the result, how we discuss the result of tests from the lab test or field test. We'll discuss this in next video. For example, this table is showing you the case of CPT, cone penetration test. In case of CPT, how can we obtain the soil information from just CPT? And it giving you some ranges for very loose soil you will have the QC will range from 0 to 2.5. QC is the cone resistance. This cone, the resistance of the cone, QC here, is measured the tip stress or cone resistance. Okay, just here, the resistance of cone, not the friction. Okay, of course, the result of CPT will give you both the friction and the QC. And if in case of CPTU, you will get also the pore water pressure. As you can see here, pore water pressure, okay? And it's saying that for the very loose, for example, soil, very loose sand, for example, the effective angle of shearing resistance, phi prime, will range from 29 to 32. And the Young modulus in megapascal will be less than 10 megapascal. So anyway, there are these ranges for every type of soil: loose, medium dense, dense, and very dense. Okay. So from the CPT result, you can get a lot of information of your soil. Okay. We will have another class, another program to talk about all these field tests, all of them, and lab tests also. So here, the objective of this program is just to show you how to design, because as I told you, we will focus more on the first part of Eurocode, not the second part, okay? Yeah, this second part is about field test and lab test, investigation, ground investigation and testing. That's the second part of Eurocode. Okay, anyway, for field tests, these are the field tests that are covered by Eurocode, the second part of Eurocode. Okay. Now let's move to the laboratory tests. Okay. For lab tests, we have the following covered by the second part of Eurocode. Okay. Test for classification, identification, and description of soil. Chemical testing of soil and groundwater. Strength index testing of soil. Strength testing of soil. Compressibility and deformation testing of soil. Compaction testing of soil, like Proctor, permeability testing to know the coefficient of permeability of the soil. Permeability testing. Don't worry, we will talk about all these tests in detail later. Test for classification of rock, because not only soil, but also rock are encountered in the field. Swelling testing of rock material. Strength testing of rock material. So we have here example, incremental odometer test, recommended minimum number of tests for one soil stratum. Okay, range of value. I hope you know what is this test. So non, medium, extensive. So variability in the odometer modulus. This is like a Young modulus, but from this test. In the relevant stress range. So if it is less than 50%, you will have this comparable experience. If you don't have experience, like none, the 4, medium 3, extensive, it's 2. 20% if it is between 20 and 50%, you have this range of when then the odometer from odometer is less than 20. Okay. So the experience matters. This is just recommendation. The most important part of this video, maybe even this chapter, is this part. The characteristic value of geotechnical data. How do you decide on characteristic value? In the previous video, we have talked about derived value and characteristic value. So the characteristic value are obtained from derived value and some other consideration of the project and soil on the construction site. So because these characteristic value are the value you will use for your design. So these value are very important. Okay. So how do we determine the characteristic value of the soil on the construction site? So the selection of in Eurocode, the first part of Eurocode 7, in this section, you can find that it's saying that the selection of characteristic value for geotechnical parameter shall be based on result in derived value from lab. So it is based on the result of the lab test and field test, the derived value. This derived value, we have defined this in the previous video. These derived value are the value obtained from the test, from the lab test and or field test. Okay. Okay. This value completed by well-established experience. So it is not only the derived value from the lab test or in field test, but also you need experience. Okay. And also basic principle. Okay. So the characteristic value of geotechnical parameter should be selected as quotient estimate of the value affecting the occurrence of the limit state. So I think the example we will take in the next video will be based on how to estimate, how to obtain characteristic value of a geotechnical parameter soil. Okay. So this section contains some general explanation. So this section of Eurocode, this first part of Eurocode 7, give also in the mode a very important guideline in this paragraph 10, and subsequent note on how to evaluate test data quantitatively. Okay. If the statistical model, because this is about statistic and probability, mainly statistic. Okay. The statistic method are used, then the characteristic value should be derived such that so that the calculated probability of the worst value governing the occurrence of the limit state under consideration is not greater than 5%. Try you minimize it as much as possible. So you should be 90% confident, okay, that it will not yield in ultimate state. Oh, sorry. So in this respect, so a cautious estimate of the mean value is a selection of the mean value of the limited set of geotechnical parameter value with confidence. Now that's what I was saying. You should be sure that a 95% that what you are doing will not reach the ultimate limit state. So means where local failure is concerned. Also, cautious estimate of the low value is 5% of fractile. In case you are using statistical method to estimate, just if you didn't understand, keep in mind that if you are using the method you are using to estimate the characteristic value is statistical method, then you have to be certain at 95% that the value will not yield in ultimate limit state. Okay, so the statistic proved formula, there are some formula for statistic, and this formula, the accepted statistic formula to evaluate the characteristic value from a set of normally distributed test result. Normal distribution, you know, probability, for those who know a little bit mathematics. Let's say the characteristic value is xk, like this, of normally distributed sample of the test result. In probability or statistics, you have normal distribution. So you take your test result because you will do many results, many lab tests, and many field tests. And I think in the previous video, I have explained this by the figure was saying F like field test and L like lab test. F1, F2, L1, L2, for example. So if you have two lab tests, these two lab tests will give you two derived value, because as I explained, the characteristic value are obtained from the derived value. Derived value are the value obtained from test, lab test or a field test. So if supposing you obtain two field tests and two more field lab tests, you have four test results. You will get four derived value, for example, for let's say internal friction angle of the soil. So if you want to use statistic, so using normal distribution, that is here, normal distribution in statistic or probability, there is distribution we call normal distribution, or that is what's saying here, normally distributed sample of the test result. So I recommend you, I'm doing actually mathematics class, but that one is only in French. But I recommend you go back and check your mathematics, especially statistic or probability. You will know what I'm talking about, because I don't want to give too much detail in here. When we will start doing example, maybe from next video, we will explain more about this, okay? Because we will take example, like actual project, to explain everything, okay? So this formula is accepted. This xk is the characteristic value. So xm is the mean value, arithmetic mean value of the test result. So means if you have two lab tests, two field tests, to make average, the mean of the result, the four results you have, okay? The 1 minus k1 kn vx, the vx is coefficient of variation. This Kn is statistical coefficient depending on the number of test results. For example, the example I'm talking about four test results. In that case, n will be 4. So that coefficient will depend on the number of the test result. It will depend on the selected probability for the occurrence of occurrence of the characteristic value, okay? For example, suppose that you have 4 value of internal friction angle and the characteristic value you choose, okay? So it will depend on that value, the probability of the occurrence of that value, okay? Because the soil is not uniform, what is the probability that this value will be obtained during the actual construction on the soil? For example, if you obtain from the 4 tests different internal friction angle of your soil, let's say you obtain 38, 42, 35, and 48. These examples for them. And after doing everything, your characteristic value is 40. Okay. So what is the probability for you to obtain exactly 40 on the field test during the construction? Because you have 4 test results and each result will give you different, each test will give you different result. Means all the 4 results are different. What will you do? There is a probability that if you take 40 as characteristic value for your design, what is the probability that you get exactly 40 on the construction side? What is the probability that you get 38 on your construction side? That's why in the previous slide was saying that you should be sure that 95% that the actual value you will obtain on your construction site will not be far from the characteristic value. Okay, so this coefficient Kn will depend on the number of test result and will depend on the probability for the selected characteristic value to occur on this site, and also whether the coefficient of variation, this Vx, is known or not. Okay, doesn't matter. So that's the meaning of this formula. Coefficient of variation also, maybe you should know. This part of this chapter is really related to statistics. So you should know, you should have good vocabulary of statistics to understand this part of this chapter. So the value of Kn can be found in many tables of textbook on statistics. Okay. Also some textbook on soil mechanics. Here are some references you can check by yourself. You can get the value. Or engineering, also ground engineering. Here are some examples. This reference proposes another formula, which is simplified to obtain characteristic mean value. Okay, this formula. In this formula, this one is standard deviation of sample. This is standard deviation also is like somehow statistic. It includes the number of the tests, includes the mean value of the tests also, and a very precise value, xi square root. I think the formula is not complicated for the standard deviation, square root, and I think x minus xi, something like that, square, you divide by, I think, the mean, the average. You can check all these. You can check online, for example, what is standard deviation in statistics. Another formula, okay? When we will do example from the next video, I think we will do more than one video for the example because we need to give more detail, much as possible, the detail so that people can understand. Now, summary of the key points of this chapter, planning of ground investigation. We did that previously. So location of the investigation point. What are the different locations you need to do? We have talked about that in the previous video. Some depths of investigation point. I think we took even an example in case of pile foundation. What should be the depth, the minimum depth? And there are 3 conditions for that. It should be at least 5 meters, something like that. There are 3 conditions. You can check the previous video. And sampling. What did we say on sampling? You need how many samples minimum, depending on the situation and what is required. Field test. This is what we did just now. Derivation of ground parameter. I think I have explained how we can get some soil parameter from CPT test. Okay, so in this video I include only CPT test example, but all the field tests can give us a lot of information on the soil parameters. Lab test also. So the minimum number of tests. Okay. This is in the table we give if you have experience, if you don't, medium experienced person, or if you don't have experience at all. Okay. The last point we talk about is characteristic value. How we derive characteristic value from the derived value that include some statistic method. Okay, statistical evaluation. Okay, I think that all. Next time we will take one example and we will try to from test result, field test or lab test to obtain characteristic value of geotechnical parameter. Okay, yeah, we will stop here. Thank you.